In this video, we're going to take a look at virtual machines and what that has to do with Ruby we'll get to a touch later in this video. First off, I'm going to use Java as the example to show you how a virtual machine works, just because I have direct access to it, and we'll talk about with regards to Ruby in a minute. So, in previous videos, we talked about interpreted and compiled languages. There's actually an intermediate form of a language where you have a language that gets compiled into what's called bytecode, and then that's run by a platform-specific interpreter. So all the interpreters are platform-specific, but having bytecode buys you is you have somewhat of an optimized code, but it's runnable on any machine because you have an interpreter that's set up for that machine. And that's what Java essentially does. So when you create a Java program, I have a little diagram here. You write your program in whatever tool you're using. You feed it into the Java compiler, and it produces this Java bytecode, which is this intermediate form of your program. Now to actually run it, you take the bytecode and you feed it into the interpreter, the bytecode interpreter, and it runs that bytecode. So I have an example here. Let me get into my directory. And okay. Now I have two files here. One is my Java file, which is my text human readable, and this is the binary byte file for Java. Let's take a look at the human readable file here. And it's that simple hello one that we covered in an earlier video. It just prints out hello. It's a very simple program, just a couple of lines. This is what gets fed into the Java compiler, and how you do that is you do javac hello.java, and that produces this file here, this hello.class. So in order to take a look at that, if we just tried to open that up in a text editor, you're going to see it doesn't look like much. There's like hidden stuff in here and binary stuff, so it's not really good form. However, there's a tool that we can use called JavaP that comes with Java, and we can take a look at the bytecode. So here's the bytecode right here. Starts right here and comes down to here. Let me actually paste this into my text editor so we can take a look at it without all that clutter. Now, the important thing to keep in mind here is that it isn't really about what this language specifically is or whatever, but it's to understand that it took your program and turned it into this intermediate form, which is kind of looks like that C language you were looking at in other videos, and almost in some ways like assembly language. And then you have the interpreter actually takes this and runs it. Now, what does that have to do with Ruby? Well, there are many people working on, with Ruby, a Ruby virtual machine. And what that'll do is it'll speed up how fast Ruby runs your program. The price that you pay for the flexibility of an interpreter or using an interpreted language is in performance because of that interpreted step along the way. And what this bytecode gets us in using a virtual machine is it gets some performance because your bytecode is a little bit closer to what the machine's natural language is going to be, so it speeds it up significantly in converting it to this kind of code. So in the very near future, we're going to see more and more of these, Ruby virtual machines just increasing our performance, and you as a programmer in Ruby need to be familiar with what a virtual machine is with regards to programming here and how you utilize it. Now, don't confuse in your mind virtual machines from the IT kind of world, such as VMware, or on the Mac Parallels. I think Parallels has a Windows product and a Linux product also, or Xen, or some of those products where you have a virtual operating system. That's a different concept completely as opposed to what we're doing here. What is important to get is that you use this virtual machine and bytecode is your intermediate step, and Ruby has that. There's ones in the works, and I'm sure as Ruby progresses here, they'll be coming out more and more because they help with performance.